this one. And even the recordings I'm uploading into my specific channels, right? You know that channel name, right? Mr. Anjan Kumar. Okay. Within that one, I know I'm uploading that in a daily basis classes. Okay. You can go there and you can see that, topic wise also. Clear, right?
Okay, clear.
Yep. So even I think you already had some kind of experience in terms of data analytics that it could be the easy for you. Okay. And even just for, just recollecting, the old information because it could help you for understanding the subject in a better way. Okay. Yep. Now I would like to talk about for today's concept is that, I would like to talk about correlation and what kind of correlations we have it and how we can able to see that, correlation matrix graphically and all. And meanwhile, we can try to understand, we can start understanding the regression analysis. Okay. It's a intro for that specific machine learning part and all. Okay, fine. Actually, for this one, let's start with the correlation. Okay, what is correlation? What is a correlation? So, what is the use of it actually? So, generally, correlation it's one of the statistical method, and majorly it could help you for to measures the okay to measures the relationship between any two or relationship, or simply we can say that in an association. Okay, and between two variables. So if we have two features or two variables, for example, please meet your systems. For example, if I'm considering this is my data set and there I have different variables are there. That means columns or features are there. Feature 2 and feature 3 and feature 4. Okay. So I want to find the relationship between, and I want to know that I want to measure the relationship between this V1 and V2 or feature 1 and feature 2. As meanwhile, I want to find the relationship between V2 and V3, and meanwhile, I want to find the relationship between V3 and V4 and V2 and V1 and okay, so V2 and V1 and relationship between V2 and V1. And so I want to find the relationship between between those things, between any two variables. Then generally we can use the correlation concept. Clear, right? I hope you understood what exactly the correlation. Correlation is just a measures the relationship between any two variables. That's it. Okay. There we do have three type of options. We might have it. Either it could be the positive correlation. What is mean that positive correlation? What is mean that positive correlation? For example, we have a V1, that means your feature one, okay? And we have one more feature that we can consider the V2. And if you try to increase the values of the V1, and it might be directly proportional to the V2 as well, that means V2 is also increases. If you try to increase the values of the V1, then automatically the V2 is also increases. That particular situation, it's a positive correlation. Or if you're decreasing the one variable, it might be affecting another one, and it is also not decreasing a mode. So this particular situation, it's a directly proportional, right? If you're increasing, then it is increases. If you're decreasing, it is automatically decreasing. That kind of relation we can call it as the positive relation. Clear? Positive correlation. And coming to the second point, it is a negative correlation. Second second result you might be get, either it could be a negative correlation. Negative correlation means, again, same example we can consider, and V1 and V2. These are my two variables. If your one variable, if you're increasing, then automatically second one is also can affect, but in a negative direction. Okay, if one is increases, then second one is decreases. If first one is decreases, then second one it might be a chance of increasing actually. Okay, clear, right? So this kind of reversely proportional, whenever we have it, that particular kind of thing, we can call it as the negative correlation. Okay. No correlation means we have one more option is there, that kind of thing we can call it as the no correlation. No correlation in the sense, if your increase or decrease of one variable, there is no change in the another one. That particular scenario we can call it as the negative correlation. Okay. Just 1 second, guys. I have to put the chat in. Any question, guys? Hmm?
Maybe I need some use case where we can
When we
relate
are
this.
building machine learning models and all, and for selecting feature selection while you're building the machine learning, that particular scenario, this is the one point we can use it. Okay, just you try to understand the concept correlation. It could help you to measure the relationship between any two variables, whether the positive relation or negative relation. Okay. So we have a correlation coefficient is there that represented we can with R, and so the formula for that one is the covariance of and any two variables, right? Here X is my variable and Y is my another variable. So covariance of the X and Y by standard deviation of X into standard deviation of Y. So this is the formula for the Pearson correlation coefficient. This particular value, if it is +1, then it is a strong, strong positive correlation. Okay. And if your correlation coefficient, it might be a negative value, that means it's a strong negative. So negative number indicating that it's a negatively correlated, positive number indicating that it's a positive correlation. And the range of the correlation value is -1 to +1. And the 0 indicating that no correlation. Clear? So for this one, we do have a function in pandas, and the function is, for example, if you have a data frame, then simply we can provide you CORR. This is the function, and you just provide that, correlation. Okay, if you just give you this particular function, and then automatically it could be finding the correlation between the all the variables what we have it. Okay. Yeah, let's say this all kind of stuff in a practical kind of stuff as well. Okay, just I'm introduced that correlation is one of the important feature. And now let's start with the regression analysis. That is a new concept, guys. Side heading, that is very much important. So when the regular regression analysis, definitely we can use the this kind of correlation concepts and all. Okay, side heading, regression analysis. Coming to the regression analysis, the main use of this one, it is also understand the relationship between independent variables or else variables. Okay. So and versus dependent variable. For example, I have a data set, and this data set I have various features are there. Okay. And so these features x1, x2, x3, x4, and this is my y variable. Okay, we can call it as this all or my independent variables, because and this is my dependent variable. Okay, so or else simply we can call it as the either it could be independent variables or else features. Okay, or else a dependent variable, or else we can call it as the target variable. Okay, see this particular, whenever we have a data set from that one specific feature, we can considering the dependent variable, remaining all, or we are considering the independent variable. The reason is that it's a totally depending on the business use case. For example, I can give you that a question is predict the okay predict the sales of sales sales. So here various product one prices and all, and here we have a sales. So we are going to be predicting the sales, right? So that particular situation, sales, it could be the target variable. Rest of things are it could be your independent variable. Whatever you're going to be predicting, whatever the label data we have it, that kind of thing we can considering the no dependent variable or else target variable. Okay, so here with help of the regression analysis, we can able to find the or we can understand the relationship between the independent variables versus independent variable versus dependent variable. Only this kind of thing we can do it actually. You might be thinking, then what is the difference between correlation and regression, right? Correlation, it is finding the relationship between independent variables versus independent variable also. Okay, And okay, so independent variable versus independent variable also. Okay, not only independent, dependent, whatever the variables we have in your data set, it is try to find the relationship between each and everything. That is the correlation. But coming to the regression, it is only finding the relationship or understanding the relationship between okay independent variables among your from your all independent variables. Okay, clear, right? So let's take in a goal or let's take in one particular use case, and from that one we can try to understand what are the dependent variable. Predict the value of the dependent variable, dependent variable, predict the value of the dependent variable like income and all. Okay, I would like to go for predict the income based on different independent variables, based on different independent variables. What are those? Like and you can consider the age or else a spending score, okay, and the job type and all. Those are all independent variables, okay, based upon the age, spending score, and the job, and their education level, and the type of the job. Based upon that one, we can able to predict the income of that specific person. So here the income, it could be the dependent variable, and the rest of all things, it could be independent variables. Okay, clear? So this regression analysis, basically we do have three type of regression analysis are there. The first one is the simple regression analysis or simple linear regression. Simple linear regression. Okay. And second one is multiple linear regression. And third one is logistic regression. Okay. See, this simple linear regression and multiple linear regression, these two are, it could help you, for to solve the regression machine learning problems, ML problems. Okay. So we do in ML, we have a two kind of two types of machine learnings are there. That first one is supervised, unsupervised, and coming to the supervised, again we have two types: regression and classification. Okay, your dependent variable, it is the number. Then that situation we can go ahead with the regression kind. If your dependent variable, it might be category or categorical, then that kind of a scenario we can go ahead with the classification. Okay, so with the help of logistic regression, okay, we can solve the classification kind of problem. But the logistic regression, which is derived from the multiple linear regression or simple linear regression only. That is the reason the name is regression. But the problem is that it could be able to solving the classification problem. Then why we are giving the name is a regression? Because which is derived from the simple linear regression or multiple linear regression. Clear? But rest of these two things like simple linear regression and multiple linear regression, it could help you for to solving the regression kind of problems only. Okay. Let's talk about the simple linear regression. Simple linear regression. Coming to the simple linear regression, let's consider I have only two variables are there. The first one is it's my x variable, and this is my y variable. Okay, I want to go for predicting the y based upon my input x. Okay, so this scenario, if I'm going with the simple linear regression, and first two things are this two are must be correlated each other. For that one, we can go ahead with the find the correlation between correlation coefficient between this x and y. Okay, if it is if your correlation coefficient value which is more than the zero, then it could be positive correlation. Which is less than the zero, it's a negative correlation. If it is the positive correlation, if it is a positive correlation between these two variables, okay, then your graph could be something like that. It is in the linear form. It is in the linear form. Okay, and that too, it's a positive linear form, because if x is increases, then automatically y is also increases. Because of that one, it's a positive correlation we are getting. If it is a positive correlation, then it's a positive linear line we will getting for over here. Okay, you can able to find the slope for that one. This particular slope, it could help you to solving the any new values mx plus c. So here m is your slope value. Okay, and you just find that this linear equation y equal to mx plus c. So you would like to go for finding the y value based upon the x value, and c is your just a constant. Constant means in some area, whenever our x value 0, that situation, this particular line, it might be intercepting of your y line. That particular value, we can call it as the constant. Okay, even our x is 0, you might have some minimal value of the y, that we can call it as the constant. Okay, slope means the change in x and the change in y, that we can call it as the slope. Okay, generally we can represent it with y1 minus y2 and x2 minus x1. That means if you are taking any 2 points on this particular linear line, and which is having the corresponding value of the x and the corresponding value of y. So this is x1 and this is y1. Okay, if you are taking one more data point or one more point on my linear line, okay, and this particular situation, you might have x1 and you might have the y value, right? So this is your x2 and this is your y2. So with help of this particular points, and we can able to find the slope of, or the change in x and change in y. And so you can easily calculate it with help of this particular formula. This is purely mathematical formula to calculating the slope of it. Okay, so I hope you understood, right? So this is if your m value is a positive, then it could be the positive correlation. If it is m value is negative, then it's a negative correlation or negative linear nature. Okay, so y is your dependent variable, and x is your independent variable, c is a constant, m is the constant or intercept. We can represent it with intercept or else constant. M is a purely slope or relation strength. We can say that it's a slope or relation strength. So if your M value is too much positive, then it could be, relation is good. Okay, too much strength. I hope you understood that simple linear regression value, right? In the meanwhile, if in case if your x is increases, then y, it might be a chance of decreases. So this scenario, if you find that the slope of this particular line, if you find the slope of this particular line, no, what happen? If you find the slope of this particular line, then your m value, it might be negative. The negative indicating that it's a negative correlation or negative relation. Okay. And okay, let's do a small example. I'm just taking the dummy data for that, for understanding the. You guys are following or not? No,
Yeah, yeah, I'm good.
following, right? Okay. Let's take a small example. I'm taking that yesterday's data only. I'm going to importing this one. This is my incoming. I have a data something like that. Income is some values. Okay, and corresponding ages also I can consider. There are total total how many data points I have here? I have 10 data points, right? And here I have the age and the corresponding incomes. Okay. And give it like some values. 23. Give me some values. Ages. 45. Okay. 33. 35. 33. 26. 29. You can give any names, guys. 40. Any values. 40. 32. Okay. And 38 and 30. Totally, how many data points?
10.
10, right? For example, if a person is having age 23 and his salary is 50,000. If age is 45, his salary is 64,000. Age is 35, it's a 58,000. Age is 33, it's a 70 some value. Okay, 26 and remove some values over here. Okay. Yeah. So this is my data points. Okay, this is my data point. Now, what I want to do, I would like to go with applying. I want to know that regression analysis. For doing this regression analysis, we can have one single method is there, that is OLSA method, and we'll try to understand that one. PD dot data frame, and we do have a data of it, and we can display this particular DF, and we have age and corresponding. Hmm, is it 10? 5,
Yeah.
5, 10. What about this one?
Select 10 only.
Yeah, 10 only, right? Okay. So now this is your age and corresponding incomes are there. Okay. Now I want to know that, how I have to define what is my X and what is my Y. Okay. My question is that I would like to go for analyzing that. I would like to go for understanding that how age is affecting the, okay, to my income. Okay. That I want to be understand, that I want to be study for that. Then we can take your age is your X, right? So how age is affecting, that means age is your independent variable, income is your dependent variable. Okay, so df of income. Okay, so this is how we can able to define your x and y data. And so you simply add your x constant, so some value we should add, and make sure that if you want to work with this particular thing, then we can in we can able to go for import a stats model, stats model model dot API. Okay. Oh, sorry. From, okay, from, and import uh, SM. Okay. So I am importing the stats model. If this is a library which is not there, then what we can do, we can install it, pip install. And what we can do, pip install
Librarian.
stats model. Okay. So this is the library name. If you provide it, then it automatically start installing in your workspace. So this stats model, it could help you for doing some kind of regression analysis, especially for a simple linear regression or multiple linear regressions. It could help a lot. Okay, so it's installed. Installation is done, right? Okay. Now what I'm doing, actually, um I would like to rerun it. Just taking the copy and run it. Yep, you are imported successfully. Then what I'm doing, actually, so when you are applying the stats model, and make sure that you need to add the constant, that means intercept value. So sm dot add constant intercept value, you can add it to your from your x data. Okay, so okay, Okay. Yep. So you added the constant. After that one, we can start building the model. I'm not doing any kind of exploratory analysis directly. I have numerical data. It is a pure format because I created this one, right? But in real time, so data, it is not easy. Okay, we have to do a lot of analysis, and we have to do so a lot of data cleaning techniques and all. Okay, so we would like to go for build the model. How we can able to build the model, and we have OLSA model is there, ordinary least square. Okay, so here we can provide your y comma your dependent variable and your independent variable, and then we simply use the fit method. Then it could be train and it can be build the model. Okay, once the model is built, then I want to see that what could be the result of it. Okay, so summary of that particular model, then we can have summary method is there. With help of the summary method, it could be retrieve lot of information. Okay, you can see this particular graph. And till the last class, I was explained so many concepts, right? Okay, it might help you like t. Okay, t value, p values, standard errors, and these are the confidence intervals. Okay, marginal errors. So it's a 0.25, and this is 97 percentage. Okay, between this constant value, you know mm, constant value between this range only. Okay, not less than this one, not greater than this one. Okay, and this is your age. And so here we can see that skewness and kurtosis values, right? Okay, and so here we can have the r square and it adjust r square, f statistic and probability statistic value, and log likelihood, and AIC BAC values. Okay, and Bayesian and ICAICA information. Okay, so Jarkobera, so Durban Watson, these are all these are all start OLSA model description. Let's so standard error assuming that covariance matrix of errors is correctly specified. So here we have a standard error, right? So this standard error is assuming that the covariance matrix of errors is correctly specified. This kind of note we are getting. And so this is the result, it could help you to understand more about it actually. Okay. So if you want, do you need to understand each and every terminology or each and every statistic value? Tell me. If you says, then I can try to explain each and every point.
Yes, Sanjay.
So first, let's start with this is the title of that one, the OLS regression analysis result. So here we are getting some name is dependent dip value. What is mean that dip value? Dip value means dependent variable. Okay. So your dependent variable is your income variable. So which model we are using? So we have various models are there, and for understanding the regression analysis. Okay. To build the various regression models, we have various methods are there. Okay, OLSA method, OLSA model is one type. This is ordinary least square. Okay, this method is least square, ordinary least square. Okay, and so today only we trained this one, right? And this particular time and all. And total number of observations. Total number of observation means here how many data points we have it. How many data points I have created over here? How many data points? These are the data points. There are 10 data points are there. So total number of observations are those things we can call it as the observations. That observations are 10. Clear?
Yes, yes.
Now let's start with R square. So your R square is 0.435. Okay. So this R square value, if it is actually this value is between 0 to 1. Okay, R square value which is between 0 to 1, and 1, if something is nearer to 1, that it could be the more actually R square, it what exactly it will do, and what percentage of variance, what percentage of variance in our dependent variable, okay, is explained by our independent variable. Here the R square value, which is explaining, or it is the study about at what percentage. So your R square is 43 percentage. 43 percentage of income. 43 percentage of income. Okay, sorry, 43 percentage of variance in income. Okay, is explained by the age. So that means not too much strong. There is some variation is there. So in some scenario, so most of the time, R square will be the good thing, but in some scenario, we are going to be using adjusted R square also. And with help of adjusted R square, what we are doing actually, we are going to be adjusting the number of predictors. Number of predictors means your age is one predictor. Okay. So we are adjusting the number of predictors with a lower than the R square value due to the having only one feature of this thing actually. Okay. And meanwhile, F statistic is also one kind of statistical method, and it simply saying that if it is less than the 0.05, okay, so no, this F statistic, it's simply explaining about overall model significance. Overall, the model, what could be the significance? Okay, and the probability of it. That means the p-value of the p statistic value. So the probability of the p statistic value, if it is less than the 0.05, the model is statistically significant. Okay, the model is statistically significant. Okay. In the meanwhile, here we can see some values like Durban Watson. Okay. So Durban Watson, it's one kind of new value. The Durban Watson value is 2.36, right? And which is close to 2. Okay. So which indicating that no autocorrelation. Durban Watson, it is explaining about is there any kind of autocorrelation, autocorrelation in residuals, that will explain by the Durban Watson. Okay. And meanwhile, Jarko Bera is JB. JB is one Jarko Bera, and which is 10.6643, and the probability of this one is less than the 0.05, and which indicating that our residuals are normally distributed or not. See, when we are working with regression or regression kind of that, so we do have various assumptions. We have various assumptions. The assumptions are, I can explain what are the assumptions are there, and residuals are normally distributed, and independent variable and dependent variables are linear in nature. Okay, and our dependent variable, it could be normally distributed. So different kind of assumptions are there, that all assumptions we can able to check with this particular statistical values. Okay, Durbin Watson, what it is doing actually. So in residuals, is there any autocorrelation? Make sure that in regression analysis, no autocorrelation. So here the Durbin Watson is saying that no autocorrelation. Or if it is a more than or less than some value, so we have some ranges there, and within that, if it is a more than that one, then there is some kind of autocorrelation. If it is autocorrelation, we cannot able to apply the regression kind of models on our data set. Okay, Jarkobera, and this values indicating that is our normal, our residuals normally distributed or not. So if it is less than the 0.05, then it could help you. It's not normally distributed. Okay, like that here we have a skew value, right? Skew is it is some kind of positive value. It's a positively skewed, slightly skewed. That means data it was not normally distributed. There is some kind of variation is there. Okay, and Kotasis value, it is higher than normal ideal value. I already told you Kotasis ideal value is 3, and if it is more than the 3, that indicating that there are so many outliers, or there could be very high tiles are there. Okay, so these are the different statistical terms indicating that will explain something about it. Okay, so we can try to take that particular statistical value and try to explore it, what is the use of it and how we can use it, and we can try to understand actually. Okay, and here we have age value, right? Your age p value, it is 0.03, right? It is less than the 0.05. So that you are saying that your age is, it's slightly relation with your dependent variable. Okay, clear? Okay. So that's how we can study of any regression results. Any question, guys?
No, Anjan. Yeah.
Okay. I use the term like outlier, right? What is outlier? I already explained you when I'm explaining about box plot outlier concept. I explained, right? What is outlier?
Outliers are those are not at all in sense with the independent variables. Means those are not at all related to the data. Means outliers need to
No,
be.
no, it's related to data only, but some you know abnormal data we have figure out. Okay, so in some situation, let's take in a
We
COVID kind of situation. Okay, so in generally, every year or every month, only few patients will be get affected with some kind of disease and all, right? Okay, that specific period of time, so many people are affected with a different kind of problems, right? No, health related problems, right? Okay, so that is one peak time. Okay, so it's a data only, which is the data, but that could be some peak time. It's abnormally we are getting that kind of stuff, right? Okay, we never expected we are getting that kind of some situations, everything is cool. We are not even register one case also. That is also some kind of abnormal thing, right? Okay, so that is also data only, but the data which is talking about information of the data set or business use case. But the problem is that there could be some kind of not in the range of what we are expecting. Okay. Yeah, so that's for today's session. I would like to continue at some advanced concepts in regression analysis. And yep, any if you don't have a question, we can wrap up our session. Acha. Yep. Thank you so much, guys, for this particular class. I can upload this particular recording into YouTube channel, and you can go there and you can access. Thank you.
thank you, Anjan.